Assalamualaikum warahmatullahi wabarakatuh. In this video, our group will present Astropy for our project for subject SFC 4053 Computational Methods in Physics. So first, our group members, first is me, Sir Ali Muhammad bin Razmi. Second, Ahmad Irfan bin Nazaruddin. And third, Muhammad Amin Nasrin bin Abdul Rahim. As an introduction, Python language has become especially popular in the quantitative science, where researchers must simultaneously conduct research, perform data analysis, and develop software. While dedicated libraries provide support for array representation and arithmetic like NumPy, a variety of functions for scientific computing SciPy, and plotting Matplotlib. Other high-quality and easy-to-use packages are also available, such as Astropy, to help with tasks that are not specific to astronomy but might be performed in the course of astronomical research, for example, interfacing with databases or statistical inferences. So here is the problem statement for this why Astropy project is developed. Several dozen of packages have been developed across the community with little or no coordination, which has led to duplication and a lack of homogeneity across packages. This creates a difficulty for users to install all the required packages needed in an astronomer's toolkit. And packages are sometimes no longer maintained or simply become unavailable, which is detrimental to long-term research and reproducibility. So why Astropy? The Astropy project is a community effort to develop a core package for astronomy in the Python language. It aims to improve usability, interoperability, and collaboration between astronomy packages. So the core package contains functionality aimed at first, professional astronomers and astrophysicists, and second, anyone who developing astronomy software. Aside from actual code, Astropy is also a community of astronomy-associated users and developers that agree that sharing utilities is healthy for the community and the science it provides.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Irfan bin Nazaruddin. Today I want to present on the Astropy parts. This part of the video will be explaining on the Astropy docs, the applications, coding, and the results. There are 4 applications used in Astropy docs. First is transforming positions and velocities to and from a galactic frame, then creating and plotting astronomical image from FITS system, and determining and plotting the altitude of celestial object, and the last one is the astronomical unit conversion of radial velocity. In this project, we will be focusing on one of the Astropy application, which is the astronomical unit conversion of radial velocity, which is the change of distance between the Sun to the GSR. Based on SIMBAT database, the velocity of variable stars can be converted to GSR using calculation of galaxies, so an average star is at rest in local standard of rest. The exact radial velocity of multiple stars data are obtained from SIMBAT and will not be the same as presented in the space database such as NASA and Astroy. Continuing to the coding for astronomical unit conversion of radial velocity. Converting radial velocity to the galactic standard of rest (GSR), most sources reported in heliocentric or barycentric reference frame. A common transformation incorporates the projection of the sun's motion. It depends on the assumptions about the orientation of GSR relative to the barycentric frame, also known as ICRS. Firstly, make brain work the same in all versions of Python and import the required Astropy packages on the code below. Use the latest convention for the galactocentric coordinates. For this example, let's work with coordinates and barycentric. As obtained, there will be used 10 samples. Below are the essential 3 values for each sample, which include RA for right extension, declination, and angular velocity. The vector has to be obtained in the assumed galactic ring from the sky position in the ICRS frame above, with the vector to project the solar velocity on line of sight used. The solar velocity using this unit vector is projected, shown below. Finally, we add the projection of the solar velocity to radial velocity to get the GSR radial velocity. This can be wrapped in functions so we can control the solar velocity and reuse the above code. Transform a barycentric radial velocity to the GSR. The input radial velocity must be passed in as parameters below, and shown below is the final line of coding. And the results are 3 inputs: right essential, declination, and radial velocity in the ICRS frame, and the output will be another frame of ready velocity in GSR. As you can see from the table 1, it shows that one sample having right extension declination and ready velocity in ICRS frame, and another table showing 10 samples of ICRS frame, ready velocity, and GSR frame. Graph is plot shown below for comparison of ready velocity in ICRS A and GSR B. As you can see, there's no trend between the reference frame and no relation can be concluded from the graph. Hypothetically, it's due to the peculiar motion occurrences in the GSR frame.
Next, we move to the part of limitation. First limitation is the regular telescope. Peculiar motion telescope can detect many objects affecting stellar objects. Results obtained differ from calculations slightly. Second is astrophy packages because need more methods to eliminate the randomness. Second is creates a clear near relation between reference frames, like image analysis tools including point spread function (PSF) and photometry. And lastly, non-stationary galaxy. Galaxy shift due to the gravity of all over dense material come and also the lost gravity from all the less dense area. Interaction of galaxies like dwarf galaxies or satellite or subsystem and local group expel some system due to gravitational force and happens. Conclusion is astrophy packages is improving and will help most of astronomers by analyzing data simulation and observation tasks will easier. And astrophy package solve their workload like CI testing. For example, like recent achievement, Google Summer of Code GSOC funded several students to work astrophy based on astrophy project. That's all. Thank you.